beyond that. Well, see, the front has this, so then on the bottom back, look at the switch. Now look at that. Like I said, so this one looked like the battery motor. So you see that light up, then you know it's working. It needs to be somewhat close. Like if you hold it down here. It's you? So this it's your choice. It's also yeah, so that's the other part of the equation. Oh yeah, that's well, I saw. No, I've heard that. Only if I leave the camera towards you. Good afternoon. Good afternoon. Thank you for braving your lunch hour and coming out. So yesterday I was up on the floor and somebody very important to me at work said, we don't have enough color in our machines. Look at all these nice green levers and things like that. We need more color. And so
I thought
maybe
you were vanity free.
we are vanity free, but if there's a purpose, if there's a reason and a purpose, you know, just like motherboards, you can make them any color you want, right? And so we make them green. So I'd like to present John Aylen and Jordan C. to talk to us about materials.
Thank you. So, as I said, my name is Jordan. I work on the infrastructure sustainability team at Facebook. This is John, who's in chemical engineering and hardware design team. So at Facebook, sustainability is a part of how we do business day to day. As we all are, we're working towards making our data centers the most efficient facilities in the world, and we're constantly trying to address our environmental impacts. So from the very beginning, we've been focused on efficiency, how we can connect the most people as quickly as possible using the fewest resources. And a lot of our work with OCP has helped us achieve that. So a big part of that is moving our electricity supply to renewable and clean resources. We met our initial goal of sourcing 25% by 2015. And we've actually doubled that goal now to 50% by 2018. But as we've grown, so is our perspective on sustainability. Efficiency is necessary, but it's not enough. So we're now looking to move beyond that by addressing how we work responsibly with the natural resources that we do use, particularly when it comes to how we design our hardware and our data centers. So today, we're going to walk through an example of how we're approaching hardware design by looking at the entire life cycle. So if you look at these life cycle phases, I already mentioned that we work hard on our energy efficiency. We're sourcing renewable and clean energy. We put a lot of thought into how they're transported to and from the data centers. and then also what happens to them when they reach end of use at the data centers. So with the goal of trying to reduce our fossil fuel inputs and emissions into our hardware designs, we decided to look at the actual feedstocks going into them. So traditionally, the bulk of the mechanical materials in our designs are steel and plastics. So we decided to hone in on our use of PCABS, common petroleum-based plastic derived from fossil fuels. And the idea was to, through thoughtful design, see if we can find an alternative material that would be able to reduce the non-renewable inputs into the system. And so we started all the way back in 2012, where we experimented with materials like PLA, which is the biodegradable material that you see used in utensils. And after a lot of iteration with us and our vendors, we were able to find a solution that would help us achieve our goals. So that is a natural fiber-filled polypropylene. I know it's a mouthful, so we'll probably abbreviate with PPNF or NFFPP. But essentially, the natural fibers provide for the renewable content, and then it's mixed with a polypropylene granulate, as well as a non-halogenated flame retardant, which allows it to achieve a V0 flammability rating. Another cool thing to note is that depending on the renewable content, the fiber content, it can be also bio-based certified. So in this instance, we're doing a direct substitution with PCBS, and that's why it kind of fit this case. And so here are just some of the comparisons of the two. In the fourth column, you'll notice that we're able to reduce the upstream carbon footprint by over 50% from cradle to gate, meaning from raw material extraction all the way to manufacturing. Another thing to note is the material is less dense. So if you're thinking about the complete life cycle and carbon footprint, that means transporting lighter materials. Here's another graph to show how it compares to the rest of traditional plastics, again, for carbon footprint. And then the last thing that I'll mention before handing to John is that we're not the first to use this material, this resin mixture. Most notably, it's used a lot in the automotive industry. And that's because we wanted to be able to find an alternative that there was a good amount of research and due diligence into the use and application of it in order to achieve our goals. So again, this is an example of, through thoughtful material choices, how we can reduce our overall fossil fuel dependencies. So now I'll hand it off to John, who will cover the technical content.
Okay, so if you're an engineer, you're wondering for something that's okay, so if you're an engineer, you might wonder, what does this mean to me? And you know the reasons why now we're doing this. Is it different than PCABS? The answer is yes. Some of the benefits, these are the reasons why, from an engineering point of view, we like it. It's available in multiple colors. As Jordan mentioned, it does come in UL 94, V2, V1, and V0 flame ratings. We have 7 different options for the resin with varying degrees of stiffness, flexibility, and other mechanical characteristics. The shrinkage, this is one of the key points. The shrinkage of the material is almost exactly the same as PCABS. This was one of the big challenges in getting this material where it is now. The reason we wanted to make it the same shrinkage rate is so that we could use the same tool for either PCABS or the natural fiber-filled polypropylene. This allows us to risk-free move forward and try it, which is what we did using it in some of our products. And at the same time, in case we wanted to retrofit or use a new material in previously released products, we could do that as well. And we're actually doing that too. It can be recycled at the end, either ground up and reused, or it can be cleanly incinerated, which, as a mechanical engineer, didn't sound all that good to me, but clean incineration is actually not a bad option for life. So we're currently using this material in honey badger, lightning, Yosemite, and you can see some of these over at our booth upstairs. We use it in the open rack for some bus bar clips and for a cable clip set that we install on the rack sidewall, and we use it in knots. We have sustainability goals, internal sustainability goals, and these, in order to meet those goals, we're trying to expand the use of this material in other products. So here's a picture of Yosemite. This is the first cubby-based sled that we've done, which uses only the natural fiber-filled polypro for all plastics. We don't use any other plastics in it. And what's interesting to note about this is that it was originally designed for PCABS. When the original design was done, we haven't qualified the material yet. However, we were able to go back to the original tooling, and with some very minor tooling modifications, adding some thin ribs in a few places to improve stiffness, for instance, we were able to use the old tooling without any other drama. But one thing that you do need to keep in mind is that the processing for the polypro material is definitely very different from PCABS. So here's some examples of how we use the material. It's very good for things like air baffles and structures. It does have some good flexibility as long as you don't expect too much out of the spring. We use it in honey badger as a combination of air baffle and full grip for our Panther Plus server part. These are some examples of our internal server components, cable management. There's some pictures there of, on the left and on the right, hard flat adapters and SSD adapters, where we're actually using it as a spring. In the case of the adapters on the right, we had another version made with PCABS, and the spring fingers were actually too stiff, but they were designed for use as an SSD adapter with the natural fiber for polypro. Something else that's pretty good at is taking a formed thread set. This is some photos of experiments that were done early on. So there's one resin which is especially good. It's a little bit softer. And what it does really well, it does it really well if you use the appropriate thread, the appropriate screw. You want to use the widest pitch that you can in your 34-inch screw with the largest thread diameter and the smallest minor diameter so that you get the most bite. We mark our parts with the number 7 recycling mark, other, and I like to put the vendor's name on it because it's such a new material and because it's not defined any other way. This way, in case the product gets its end of life someplace out of our control, for instance, if it was sold outside Facebook and they go to recycle it, they'll know to at least contact JPS Eco and find out where can they recycle it or how can they recycle it. Now here's the more detailed part, technical part. Because it's not PCABS, even though you can use the same tool between them, you do have to take a good deal of care in the processing. And the initial setup is the most important part. So you can keep in mind other reinforced plastics when you're doing your part design. Just use that as a rule of thumb. Like a glass-filled nylon is a good example. You want to have a sufficient number of gates to let the material flow. And sometimes with PCABS parts, you might need to add or enlarge an existing gate for the material. You want to have them evenly distributed so that you don't have uneven pressures. And you might need to add some small guide ribs. We have one example where a very long, thin wall warped a little bit, but we added in a couple thin ribs and it fixed the problem. Mm-hmm. Of course, add sufficient draft angles. You're not going to get away with 0-degree draft angle on parts like this, and we're off to it too fast. And consider using more ejector pins than usual. And the tool wear is similar to other filled plastics. So we've put all of our products through the same environmental shock and vibration testing that we do with all of our server and storage devices. And it's passed all of our tests without any problems. So we did environmental testing as well. What we did find was that in one corner case, if the pellets are not dried appropriately, if they're not dried according to the spec long enough at the correct temperature, then some residual moisture can remain inside the fibers inside the pellets. That you would never notice that unless you also didn't have quite high enough mold temperature and quite high enough injection pressure and a high enough hold time. You'd have to have a perfect storm to see it. We saw it. We found out that if you do all that and then put it into a poly bag in a humid environment, some moisture does leach out of the fibers, creating a very thin white film on the surface of the part, which didn't have any. It was only cosmetic. It didn't have any functional deficiencies. We just wiped it off, but we made an SOP for how to package it, which involves just packaging it in a cardboard container with divided sections instead of a poly bag, just in case. Here's some storage environmental testing. We tested it with our PC boards mounted and with the sheet metal brackets mounted to the parts of Honey Badger. And again, within our environmental test chambers, there was no adverse reaction between PC board material or the sheet metal and the natural fiber filled polypropylene. So these are some of the important things that you need to keep in mind. Injection pressure is really important. So the injection pressure, the injection speed, the whole time after the injection has occurred, you need to measure the temperature of the material at the barrel. You need to measure the mold temperature. And by that, I don't mean set the temperature on the water heater and walk away. I mean, you need to actually set the temperature on the water heater and then check that temperature on the core and cavity side of the mold on the surface itself. And we need to do this as part of the initial bring up. The injection point temperature at the end of the injection barrel is important. What we found is that there can actually be a 15-degree C delta between what the water heater display says and what's actually hitting the coupling at the mold. So that's why we shouldn't trust, at least you can get away with it with other materials, but you shouldn't trust the heater display for the heating the mold. And as I mentioned, you have to dehumidify the pellets. Don't rush it, don't skip it. Nothing may happen, but something like that. And here's an example of that white residue that I mentioned. As I mentioned, it's only cosmetic, but it was raised by one of our quality control engineers, and that's what we found out. Now for coloration, this is the material in its natural color. One thing about Facebook, as was mentioned earlier, we're not about cosmetics, we're vanity free. We do use colors, we do use green as touch points in our servers, so that technicians they can more easily understand where they should be doing the service event. So we originally did our testing without any consideration of color. We wanted to see if the material was going to work. So we had some very large parts made. This is a large air baffle that was shot off of PCABS tool. It was a very early trial shot about 3 years ago. If you use black, then the surface texture that you can see is a little bit uneven. The black hides it very well, and the green does an okay job. So a lot of people ask if you can paint it. The answer is yes, but I would say, first of all, we don't want to paint it because we want to be able to recycle the material. But if you insist on painting it, then you need to take into consideration the surface texture, which it wants to not be smooth. It wants to have something for the paint to grip onto. And it may also be necessary to heat treat, the flame treat the surface before painting for better adhesion of the paint. What we found is we did a sample of about 1,000 pieces, and we had an unacceptably high fallout of that because in areas that weren't properly treated completely, the paint would actually scrape off the to scrape up against something hard. So we went through, we did the standard nail scratch tests and found that it couldn't pass cosmetics for consumer level good, for instance. So that's when we started looking at the green tint option instead of painting. And in our data center, the technicians agreed that the brighter, although we can't reach the same brightness with the tint as we can with paint, the fact that it's a more earth-friendly material is more than acceptable. Another way we use it is we have these cable clips that we add to the side of our racks. These are for managing the network and storage cables. Historically, we've used Velcro. So one of the things that we had to test was, would the double-sided adhesive stick to the natural fiber polypropylene over time, over heat and over humidity? And we ran it through the same test we ran everything else through, and it passed just fine. You do need to take care to prepare the surface properly with a 50-50 mix of alcohol and water first. So these are some of the resin options and the properties. So, you know, as Jordan mentioned, we try to keep the life cycle in mind when we're doing our design. And we want to minimize the carbon footprint of the things that we can control. And the natural fiber flow polypro can improve this by more than 50% as compared to PCAPS. This material is supplied by JPS Eco in Taiwan. There's their information if you have any technical questions. They also have a representative that's over at our booth for some samples and some business work. Oh. Any questions? Yeah.
Other vendors besides this particular one, have you ever looked at?
Yes, we have. There are other vendors out there. This is not the only one, and certainly there are other options besides this particular natural fiber filled polypropylene. We chose this for our own reasons, and it was a 4-year development cycle with JPS Eco, so it's not a trivial thing to get dialed in the way we wanted it to.
And how does cost compare?
It is slightly more expensive than traditional PCABS. Yes.
Is the polypropylene content 100% virgin, or is there some recycle in that stream, material stream as well?
You'd have to ask Simon at JPS Eco the question. I believe that both options are available. Yes. We've looked at that. We've actually started doing that. This is one of 3 structural pieces inside Yosemite, which replaces a piece of sheet metal. We would traditionally use sheet metal stamped car guides for this. So this displays that. We used to use sheet metal covers. Actually, one of Jordan's photos showed a very early sheet metal cover air baffle that we used. We're now doing it out of this material. So we looked at trying to make a tray out of it, but the tray has to be very stiff. And injection molding this into a tray form factor is possible, but it didn't work for our application at the time.
What is this used for your recycling and dismantling of old products that are no longer, if they're expired, right?
Okay. Go ahead.
But the feedback from them, they can look at this stuff and this will fit into their process well.
This gear has a reach. So, but we're in the meantime setting up.
Well, thank you very much.
Thank you.
Thank you.
块就在找我们，看不到了。
No, after you. Get caught everywhere. Hello. Sharp Jack.